All right, so in this lesson, we're talking about forces still. We're kind of applying friction into this. This is kind of one of the really big focuses of this unit. Friction is kind of a weird force. For example, right here on our mass, we don't have any friction, right? It's got gravity pulling down and it's got this normal force of the table pushing up. It's not going anywhere, so it's balanced, but there's no friction associated with it. But if we come along and we give it a little push, not much, just enough to apply force, but that it doesn't move. Why doesn't it move? It doesn't move because there's another force pushing this way. Remember, we talked about those balanced forces. If we have a force pushing this way and a force and it's not moving, we have to have a force pushing the other way, right? That's that balanced force situation. So there is friction. It just changes. So what if I apply a little force? We have a little bit of static friction because it's not moving. What if I apply a bigger force? Still doesn't move, so it's still that static friction. It's just a bigger force. So the force is changing. So that friction force can change with the amount of forces that we're pushing in that other direction. Now, if I give it a little push and move it with a constant velocity, those forces are still balanced because it's moving at a constant velocity. But the friction has changed. So now we have kinetic friction, right? So I have this applied force going this way. I have a friction force going that way. And those are balanced because it's moving at a constant velocity. So in this lab, what we want to investigate is that coefficient of friction, that ratio between the normal force and the friction force. And it has to do with the surfaces in between. Now, the first thing that you're going to have to do is find the mass of your block and whatever you're putting on top of your block, right? So we have to find that normal force. So normal force, if you think about our normal force, we're on a level surface. So we have gravity pulling down, we have normal pushing up. Since it's not moving, that normal has to be equal to the gravity. So as long as you stay on a level surface, your normal force can be found by determining the force of gravity. Now remember, we can do that with our gravitational constant that we found in the last lab. So we take that 9.8, we multiply it by our mass, that's going to give us our normal force, okay? So then what we're going to do, you're going to need a block. Your kit comes with a block. It depends, I don't know, it depends. Different ones have different things. Like this one has a mirror on, there I am, has a mirror on one side and has sandpaper on the other. This one just has wood on one side, this has sandpaper on the other. It doesn't matter what the surfaces are. You're going to compare them on different surfaces. So we're really looking at how that friction changes between different surfaces. But you're going to take your block. I'm just going to put it here. All right. Now, your spring scale, depending how strong it is, how much it can actually pull, is going to determine what you can put on top of this block. Your lab says, I believe, put pop cans on it. Those are super helpful because you can put it on there and then you can stack them. But if your spring scale isn't very big, you might not be able to pull them. So you need to find something that's going to fit on top and still be pulled without maxing out your spring scale. So you're just going to take this and you're going to hook it up to your spring scale like this. Okay. Put some mass on it because I'm pretty sure I can't do this. All right, so you're taking two different sets of data. We're finding the normal force, but then we're going to take this and we're going to pull it. Just pull it very gently. And what you're looking for is what is the maximum force that your spring scale will read and still not move. Okay? We're looking for our maximum static friction force. And so this is kind of tricky, and you'll get a little bounce. You'll get kind of a little jump up. That's what you want to read. All right? So whatever number you get as your newtons, don't forget your newtons, not your kilograms. So your Newton force just before it starts to move. That is your static friction force. The second set of data that you're going to take for each mass, you're going to pull it. Now this is the tricky part. You want to pull it with a constant velocity. That's the hard part. Well, pulling it with a constant velocity and reading it at the same time. This is a tricky lab to do. So if you have a partner or somebody who can help you read this, even better. So we're going to pull this with a constant velocity. We know it's a constant velocity if your spring scale is not bouncing. Okay? So you're going to read And it doesn't matter how fast you pull it, you just want it to be constant. You're going to read whatever force that is your kinetic friction force. All right? So you have your static force is the highest force without it moving. Your kinetic force is going to be whatever constant velocity that is. And then you're going to add more or less mass. And you're going to change your mass and do the same thing. Now the really important thing is to make sure that when you pull this, you pull it with the same velocity every single time. All right, so this is going to take some practice. So we want to pull it with the same velocity every time. I don't know, does that look faster, slower, or the same as it did before? That's what you're going to have to do. Now obviously you're going to pull with more force if there's more mass, but you want it to be going the same speed as we go across. Okay? So that's how your lab is set up. You are looking at the relationship between the normal force and the coefficients. So you're going to have two graphs. One is going to be with your static frictions. One is going to be with your kinetic frictions. Since we are changing the normal force, that's going to be our independent variable. That's going to be the variable that goes along the x-axis. And then we're looking at how those kinetic and static friction forces change, so those will be on our y-axis. When you graph that, that will get you your coefficient of friction. So that's going to tell you about the coefficient of friction in between those two surfaces. All right? So then you're going to do that with, I think, two different surfaces, and then draw some force diagrams for those. All right? So pretty straightforward, a little tricky in the whole keeping everything constant between your trials, but pretty doable all around.